This short video is on the factors that affect climate, specifically relief. Okay, so let's get started. Imagine this object is a mountain. When it comes to relief, there are two general principles that you need to understand. The first is that landforms act as barriers to land masses. The second is that air masses are forced to rise over land masses. So let's take a watch. Whee! Okay. The other thing you need to remember are the rules of climate and elevation. They are: when air masses rise, the temperature gets colder by 1 degree Celsius for every 100 meters, unless there is precipitation. Then the air mass cools at 0.6 degrees Celsius for every 100 meters. When air mass loses elevation, the temperature gets warmer 1 degree Celsius for every 100 meters, unless there is a precipitation. And then it warms 0.6 degrees Celsius for every 100 meters. Now let's take a look at how these two factors combine to affect climate. First, take a look at this diagram. Again, imagine it to be a mountain. And in the bottom left-hand corner, just for fun, we're going to add an ocean. Imagine a warm air mass floating above this warm ocean. Because the air mass is warm, the molecules are far apart. This allows moisture from the ocean to evaporate into the air mass. The air mass is then pushed by winds onto the mountain. The wind then forces the air mass up the mountain. The air mass cools as it goes up the mountain at a rate of 1 degree Celsius for every 100 meters, or 0.6 degrees Celsius for every 100 meters, depending on the conditions. The molecules within the air mass are forced together, and thus the moisture is forced out of the air mass in the form of precipitation. The precipitation falls as rain, snow, or ice, depending on the temperatures. As the molecules in the air mass get pushed closer and closer together from its cooling, it wants to go back down towards the ocean. However, it cannot because it is being pushed up by the wind until the air mass reaches the top of the mountain. At the top of the mountain, the air mass immediately starts to go down the other side of the mountain very quickly. This is because the air mass is so dense. As the air mass goes down the mountain, it warms up 1 degree Celsius for every 100 meters. This creates a warm wind known as a Chinook. Also, as the air mass goes down the side of the mountain, the precipitation almost immediately stops. This is because as it warms, the molecules within the air mass are starting to spread apart, allowing moisture in. Thus, it evaporates any moisture on the side of the mountain. This creates a rain shadow on the side of the mountain, is the primary reason the prairie provinces are so dry, as the air mass heads out that way. The side of the mountain that received all the precipitation is known as the windward side, and the dry rain shadow side is known as the leeward side. Well, that's it for this short video on the factors that affect climate, in this case, relief. Check out the other videos in this series. They are latitude, ocean currents, wind and air masses, elevation, and near water. Well, hope you're having a great day. Bye for now.